Hello everyone. In this video we are going to study about the stability of a system. So first we will see what are the conditions to find out the stability of systems. Then what is a stable system, unstable system, marginal stable system. Then Routh Herwitz criteria. There are different methods to find out the stability of a system. We are going to see the Routh Herwitz stability criteria and we will see two examples of Routh Herwitz criteria. So first, stability of system, which is system is said to be stable. So if the output of any system is under control, then the system is said to be stable. If the output is under control, then this system is said to be stable system. A stable system produces a bounded output for a given bounded input. That means this is also called as bounded input bounded output stability criteria. Okay, so here the output is bounded. This is the example of output bounded output and bounded input. This system is said to be stable. That means it produce specific output at the specific input, or we can say that linear output to the bounded input. Next, conditions for stability. So what are the conditions? First, the coefficient of characteristic equation should be real and have the same sign. None of the coefficient should be zero. So in the characteristic equation, the coefficient should be real and should have the same sign, and they should not be zero. Then all poles roots should confine in left half of S planes that have that means they should have negative real path. Suppose this is my S plane. Okay, this is S plane where this is sigma real axis, this is j omega imaginary axis. So here all poles means the poles, so all poles should confine in left half of S plane. So the system is said to be stable. Okay, a stable system, definition of a stable system, any linear time invariant system is said to be stable when first condition is for a bounded input it should produce bounded and controllable output. So whatever the input specific input is there, it should produce the specific output and controlled output. Then next point, in the absence of input, the output must tends to zero irrespective of initial conditions. So whenever there will be no input, then output should be zero. So this is S plane, and the poles should confine in left half of S plane. So this system is said to be stable because the roots are on negative real axis. Okay, then what is unstable system? So any linear time invariant system is said to be unstable if first condition for a bounded input it produce unbounded output. That means the output is not linear or not it is not bounded. Then in absence of input, output may not returning to zero. Now when the input is absent, there will be no input. If there is a no input, then output is not returning to zero. So this is called unstable system. So here the poles are at right side of S plane. So this system is said to be unstable system. Types of system based on stability. There are different types of system which are based on stability. First is absolutely stable system. So if the system is stable for all the range of system components value, then it is known as absolutely stable system. Conditionally stable system, if the system is stable for a certain range of system components value, then it is known as conditionally stable system. So here absolute stable system, if the system is stable for all range of system components value, that means it should be stable for all the range of that system components value. So here and in conditionally stable, it is for a certain range of that system components value. Next, marginally or critical stable system. So any linear time invariant network or system is said to be marginal or critically stable if there is condition. First condition, for a bounded input it produces oscillations at output with constant frequency and amplitude. Such oscillations are called as undamped or sinusoidal oscillations. So here in marginally stable, the input is bounded but the output is a oscillation form in the form of oscillations form with a constant frequency and constant amplitude. So such oscillations are called as undamped oscillations or sinusoidal. This is sine wave. Here this is amplitude 1 volt minus 1 volt. So the all peaks should be plus and minus, and the distance between this, that is time, it should be constant. So constant amplitude and constant frequency. So such type of oscillations are called undamped. Now what do you mean by damped and undamped? Damped oscillation means which reduce with respect to time. This is, suppose this is 1 volt plus minus, okay, then after some time it becomes, it reduced, and here it gives zero value. So this is called damped oscillation and this is called undamped oscillation. So oscillations. So the marginally stable is the roots or the poles or the roots of the equation, characteristic equation, are on the imaginary axis. So this system, when the poles are at imaginary axis, then the system is said to be marginal stable. But the first one condition is no repeated roots on j omega axis, but there should be no repeated root. If that are repeated root, then it is said to be unstable system. Then Routh Herwitz criteria. So this is the method to determine continuous stability of a system. Okay. Then what are the necessary conditions for this criteria? So all the coefficient of characteristic polynomial equation should be positive. That means the roots of characteristic equation should have negative real parts. That means all coefficient should be positive. That means the roots of characteristic equation should have negative real parts. For the characteristic equation, a0 s raised to n plus a1 s raised to n minus 1 plus a2 s raised to n minus 2 plus up to an is equals to 0. So to find out stability by using Roth Horvitz criteria, first is to find out the array. We have to find out the array. So method to form an array. Uh, this is the method. This is the method to find out the array where s raised to n is having a0 coefficient, a2 coefficient, a4, and up to an coefficient, and s raised to n minus 1 is a1, a3, a5 up to an minus 1, and then s raised to n minus 2, and this are having b1, b2, b3 up to bn, and then s raised to n minus 3 will have be having c1, c2, c3 up to cn, and this is up to s0, s raised to 0, an. So first two rows, s raised to n and s raised to n minus 1, are the coefficient of this characteristic equation a0, a2, a4, and the next row is a1, a3, a5. So these are the coefficient of the characteristic equations. To find out b1, there is one formula to find out b1: a1 into a2 minus a0 into a3 whole divided by a1. So this is the formula to find out the b1: a1 into a2 minus a0 into a3 divided by a1. Then to find out b2: a1 into a4 minus a0 into a5 whole divided by a1. So this is b2: a1 into A4 minus A0 into A5 divided by A1. Then to find out B3, A1 will be multiplied by next number of A4. It will be A6. Okay, so here A1 into A6 divided minus A0 into the next number will be A5. After A5, next number will be A7. So into A7 whole divided by A1 only. So it will be B3 A1 into A6 minus A0 into A7 divided by A1. So in this manner we have to find out B4, B5, B7. Then to find out C1, the formula will be B1 into A3 minus A1 into B2 divided by B1. So here C1 will be B1 A3 minus A1 A2 divided by B1. Then to find out C2, there will be B1 into A5 A1 minus A1 into B3 whole divided by B1. So this is C2, B1 into A5 minus A1 into B3 divided by B1, and so on. Then conditions for Routh Herwitz criteria or stability, all the elements of the first column array should have the same sign. So the all the elements of first column, this is the first column. So the all elements of this first column should have same sign. Array should be either positive or negative, but they should have same sign. All these elements should have same sign. We will see one example. There is a one characteristic equation: 3s cube plus 3s square plus 2s plus 1 is equals to 0. So first step, verify that all the coefficient of characteristic polynomial equation are positive. What is the first step? Just we have to verify that the all coefficient of characteristic polynomial equation are positive. So here the all are positive, then we will proceed towards the next step. Then compare with the standard uh, characteristic polynomial equation, then it will become a0 will become 3, a1 is equals to 3, a2 is equals to 2, and a3 is equals to 3. Now what is the step 2? Then form an array. We have to form the array by using this values, s3, then s raised to 3, it will be a0. So a0 will be 3, then a2 is 2, then next s2, this will be a1 and a3. So 3 and 1. Now to find out b1 here, to find out b1, the formula is a1 into a2 minus a0 into a3 divided by a1. So what is a1? So here 3 into 2 minus 3 into 1 divided by 1. And to find out b2, the formula is a1 into a4 minus a0 into a5 divided by a1. So by using these two formulas, we are going to find out b1. So b1 will be equals to 3 into 2 minus 3 into 1 whole divided by 3, that is equals to 1. And b2 will be equals to 3 into 0 minus 3 into 0 divided by 3 equals to 0. Why 3 into 0? Because we do not have a4 and a5. So instead of, so a4 and a5 will become 0 0. So here b2 will be 0. Then find out c1 and c2. So to find out c1 c2, these are the formulas: b1 into a3 minus a1 into b2 divided by b1, and C2 is B1 A5 minus A1 B3 divided by B1. So C1 will be equals to B1, that is 1 into 1 minus 3 into 0 divided by 1 will be equals to 1, and C2 A1 into 0 minus 3 into 0 divided by 1 equals to 0. So this is my array. So next step, check out all the elements of first column should have same sign. So is there any sign change? So said there is no sign change in first column of Roth array, so the system is said to be stable system. Then there are some special cases of Roth array. There are two special cases. First is if the first column of any row of Roth array is 0. See, here only the first element of S1 row is 0 and the remaining element have non-zero value. See, this is the one example of Roth array. Here, first element of this S1, this is my S1 row. The first element is 0 and the remaining element have non-zero value. The remaining element is 1. So here, first is 0 and next is a non-value. So then we have to replace the first element with a small positive integer epsilon. So we have to replace the 0 by epsilon and the continue the process of completing the Roth's table. Okay, to find out the number of sign changes in the first column of Roth's table, then substitute epsilon tends to 0. So we will see one example. This is my characteristic polynomial equation: s raised to 4 plus 2s cube plus s square plus 2s plus 1 is equals to 0. First step, we have to verify that all coefficients should be positive. So here all coefficients are positive. Then we will compare with the standard equation. So this will become a0 will be 1, then a1 will be 2, a3 is 1, a4 is 2, a5 is is compare with the standard equation. So a0 will be 1, a1 will be 2, then a2 will be 1, a3 will be 2, and a4 will be 1. So next step, form an array. So by using this coefficient, we are going to form the array. So S4 will be A0, A2, and A4. So all values are 1. Then S3 will be A1 and A3. So 2, 2. Then form B1, B2. Now here, see in this particular row S3, so all elements of S cube are divided by 2, as it have common factor 2. So 2 by 2. So divide this whole row by 2 and it will become 1. So here this S3 become 1. Now we are going to solve this. We have to find out B1, B2. So now to find out B1, B2, these are the formulas. So B1 will be equals to 1 into 1 minus 1 into 1 divided by 1 will give you 0, and then b2 is give you 1 into 1 minus 0 into 1 divided by 1, that is 1. Now here first element of S2 row is 0 and the other element is non-zero, so replace this 0 by epsilon. Now find out C1, C2 by using these formulas. So C1 will be epsilon into 1 minus 1 into 1 divided by epsilon, which will become epsilon minus 1 divided by epsilon, and C2 will become 0. Then find out D1. So D1 will be epsilon minus 1 divided by epsilon into 1 minus epsilon into 0 whole divided by epsilon minus 1 divided by epsilon, which will give you 1. Now to examine sign changes, we have to take the limits. So limit epsilon tends to 0, epsilon minus 1 divided by epsilon will give you minus infinity, as epsilon tends to 0. So 0 minus 1, that is minus 1 divided by 0. So anything divided by 0 is infinity, so minus infinity. So here it will be 1. First column of row survey will be 1, 1, 0, minus infinity, and 1. So here in this first column there are two sign changes, and there are two sign changes in the first column, therefore the system is said to be unstable. Two sign changes means from positive 0 to negative infinity and from negative to positive. So there are two sign changes in first uh, column of row table, so this system is unstable system. The next case is if all the elements of any row of Roth array are 0. Here all elements of this S2 row are 0. Then what we have to do, if this whole are 0, then the right auxiliary equation A of S of the row above to the row of 0 means this S2 is the all element of S2 row are 0, then take the above row, that is S3, and make it write the auxiliary equation for this particular row and differentiate that auxiliary equation with respect to S and fill the row of zeros with these coefficients. Now, example S5 s raised to 5 plus 2 s raised to 4 plus s cube plus 2s square plus s plus 2 is equals to 0. Now, first step, verify the all coefficients should have positive. So here all coefficients are positive. Then compare with the standard equation. So here a0 become 1, a1 2, a2 1, a3 2, a4 is equals to 1, and a5 is equals to 2. Then form an array. So by using this coefficient, form the array. S raised to 5 will be a0, a2, and a4. So 1 1 1. Then s4 s4 row will be equals to a1 and a1 a5 and sorry a1 a3 a5. So 2 2 2. Now here you see this row all are divided by 2, or all elements of S4 are divided by 2 as it has a common factor 2. So divide this whole row by 2, it will become 1 1 1. Okay, so to find out b1 b2, these are the formulas. So here b1 will be equals to 1 into 1 minus 1 into 1 divided by 1, which will be 0. Then 1 into 1 minus 1 into 1 divided by 1, and it will be also 0. Now here see this row, the all elements are 0. So what we have to do, if the all elements are 0, so step 2, write the auxiliary equation for the above row of 0. So this is S3 s raised to 3, this row is 0. So write the equation for auxiliary equation for the above row, that is s raised to 4. So we have to write the we will write the auxiliary equation for s raised to 4 row. So it will become s raised to 4 plus s raised to 2 plus 1. Now differentiate this equation with respect to s. So it will become 4s cube plus 2s. Now place this coefficient 4 and 2 in s cube row. So it will become s cube will become 4 and 2. Now again all the elements of s cube are divided by 2 as it have common factor 2. So 4 divided by 2 will be 2, and 2 divided by 2 will be 1. So replace that by 2 and 1 and form the arrays by C1 C2 D1 by using the formulas. So the C2 C1 will become zero point 0.5, C2 will become 1, D1 will become minus 3. So here and E1 will become 1. So here in the first column there are two sign changes from positive zero point 0.5 to negative 3 and from negative 3 to positive. So there are two sign changes in first column of row that table. So the system is said to be unstable system. Hope you have understood what are the stable system and how to find out the stability by using Routh Horwitz criteria. And there are two special cases. I hope you have understood.